It could be a way of capturing CO2 and reducing climate impact, or a way to clean the air from pollutants, or it could be a way of efficiently releasing medicine into your body. The sponges Ken Inge and his research team at Stockholm University are developing have a number of important applications.
So essentially what we're making are nanoporous materials which function just like sponges. We can use the sponge to soak up substances, store it, transport it, and release in a controlled manner.
The sponge-like material that Ken Inge is developing is called a MOF. That's a metal organic framework, which is organized into porous three-dimensional network structures. The researchers can control the size and shape of the pores and construct them so as to be a perfect fit for a large variety of molecules they want to capture. This opens up a variety of applications.
One of the applications we have for the metal organic frameworks we've developed is for drug delivery. So that means we will store pharmaceutical compounds inside the pores of our metal organic frameworks. And then with some time, we can control the release of these pharmaceutical compounds, say in the body or on the surface, on the skin.
The material is also highly efficient at capturing large quantities of carbon dioxide or other types of air pollutants, such as sulfur dioxide or hydrogen sulfide. Nanoporous materials similar to MOFs can also be found in nature and have been known for hundreds of years. For example, the class of minerals known as zeolites.
So zeolites have a wide variety of applications. We can find them in our laundry detergent as water softeners. They've been used to capture radioactive ions, for example. In the Fukushima incident in Japan, tons of zeolites were dumped in the water to capture radioactive cesium. But these metal organic frameworks that we work with, they've only really been developed over the last 20 years, which makes it a young class of materials.
Today, these crystals often are typically expensive to produce compared to zeolites. Also, they're often made out of molecules derived from non-renewable resources, such as crude oil. Ken Inge wants to make them cheaper and greener.
These metal organic frameworks, we can make them out of all sorts of metal cations. We can make them out of all sorts of organic molecules. It's really up to your imagination what you want to create. So with the metal cation, we've really focused on non-toxic metal cations. For example, bismuth. Even though it's a heavy metal cation, it's very non-toxic.
In addition, bismuth also offers health benefits since it's antimicrobial and kills bacteria, which is useful when using MOFs for transporting medicine. For the organic molecule in the MOF, the researchers use natural antioxidants, so-called polyphenols, which can be extracted on a large scale from waste materials, such as tree bark or fruit peel.
Så det vi gör för att skapa vårt material är helt enkelt att ta en molekyl, i det här fallet isolerad från granatäpplen. Och vi blandar den tillsammans med en kation, som är vismut i vårt fall, i vatten. Och så kommer vi få ett tredimensionellt material. När reaktionen är färdig, då tar vi helt enkelt vår lösning, häller av det och låter det filtrera. Då har vi då erhållit våra kristaller, alltså vårt färdiga pulver, som vi kan använda för diverse applikationer.
To be able to study the material at an atomic level, the researchers use an electron microscope.
In order to look at it in the transmission electron microscope, we now need to place it in a sample holder. So now we are ready to go. So this transmission electron microscope is at the top level in the world, and it really helps us to study these crystalline materials.
Understanding the structures of these MOFs will enable enhanced nanoporous materials to be produced from green renewable resources in a cost-efficient manner and on a larger scale.
I love research. It's just such a delight coming into work every day, thinking about what sort of new materials can we develop, what sort of structures are we going to solve today. For me, work is just a delight, and I love what I do.